ओके, मेरी आवाज आ रही है? कैन यू हियर मी? मेरी आवाज आ रही है?
हाँ सर।
ओके, जरा ये कैमरा ऑन कर लो फटाफट। कैमरा ऑन। कितने मिनट्स? 13। ओके, सो लेट्स शेयर द बोर्ड। हम पहुंच चुके थे, हमें दिखाना था। चलो, हमने एक सीक्वेंस ली, हमें उसकी कन्वर्जेंट सब सीक्वेंस दिखानी, वीकली कन्वर्जेंट सब सीक्वेंस। सो फार वी हैव रीच्ड दैट। व्हाट हैव वी रीच्ड? तो हमने ये किया था कि x and n comma x does converge if x belongs to span of the sequence जिसको हम कंसिडर कर रहे हैं, जिसकी ये सब सीक्वेंस है। सो फिर हमने लिया था m equal to the closure of this span, which would be a closed subspace. तो हमने इसका क्लोजर लिया। सो देन फिर हमने x लिया था यहाँ पे m में, so that we had ym converges, so we had a sequence ym inside the span of the sequence of these vectors. तो हमने किया था कि then ym, sorry, क्लोजर में नहीं होगा, तो ym कन्वर्ज करता है x को, और हम दिखा चुके हैं कि then x and n comma x is equal to limit m approaches infinity y m x। लेकिन वो तो इसमें बिलोंग करता है, और जो भी इसमें बिलोंग करता है it converges where whatever belongs to span। तो m कितना कुछ भी हो, infinity के पास भी हो, then this is weakly convergent. Now since ymx is weakly convergent, is convergent for all m, it implies that x and m x converges for all x belonging to m, which is a closed subspace of H. Because linear span is always subspace, उसका closure लेंगे तो वो close भी हो जाएगी, closed subspace of H. Now by projection theorem हमें कहता है H can be written as m plus n perp for any closed subspace. So therefore, if x belongs to H, then x is equal to y plus z for some y belonging to m and z belonging to m perp. Okay, and therefore and x n and x जो होगा, this can be written as x n comma n y plus z, which by the property of the inner product should be x and n comma y plus x and n comma z, where of course y belongs to m and z belongs to m perp. लेकिन हमें पता है x and n जो है they belong to m, है ना, because m is the closure of the span. तो जो भी सीक्वेंस की टर्म्स हैं वो m में बिलोंग करती हैं, तो therefore उसकी सबसीक्वेंस की टर्म्स भी m में बिलोंग करेगी। तो उसका मतलब क्या हुआ, बट मैं लिख सकता हूँ x and n comma z जो है वो 0 होगा, because z belongs to m perp, because x and n belongs to M. So therefore, x and n, x is equal to x and n of y. So which is convergent. So therefore क्योंकि y belongs to m और y belongs m के हर एक वेक्टर के लिए हम ऑलरेडी प्रूव कर चुके हैं. So ये कन्वर्ज करेगी तो ये भी कन्वर्ज करेगी. So therefore which is convergent. एक हिस्सा हमारा हो गया. Therefore I can say that x and n comma x is convergent, is a convergent sequence, is a convergent sequence for all x belonging to H. So therefore, so we we can define f from H to K by f of x is equal to limit n approaches infinity x xn. Well, this is well defined. Actually इसका हमने conjugate लिया just to make things a little easier. लेकिन अगर ये converge करता है तो इसका complex conjugate भी converge ही करेगा, right? The sequence of complex numbers converges, then so should the sequence of its conjugates. क्योंकि जब हम इसको modulus में लेंगे, suppose you got xn minus mod x. What do we want to say? That we want to say that xn minus x जो है converges to 0. So that means xn bar minus x जो भी है वो भी converge करेगा 0. तो अगर xn converge करेगा तो xn bar भी converge करेगा. So anyway, so मेरे कहने का मतलब है this is well defined. Then f is linear. Then f is indeed linear. Why? Because of the properties of the inner product f of x plus y, whatever n. So this defines because the limit exists, it's done. F is linear, and mod of f of x to over it will be equal to limit n approaches infinity x comma x and n. This is equal to limit n approaches infinity norm of x into norm x and n. लेकिन हमें पता है ये तो it's a subsequence of a bounded sequence. हमने यहाँ पे Cauchy-Schwarz inequality use की और साथ में ये भी किया कि modulus is a continuous function, so I can take it out, then apply the Cauchy-Schwarz inequality. I should write less than equal to, sorry. So less than equal to this thing. So which is less than equal to some k times norm of x, because xn and it will be less than equal to some k. So therefore fx is less than equal to k times norm of x for all x belonging to H, implies that f is a bounded linear function. It's linear and it's also continuous. So therefore f therefore by these representations here, there exists a unique y belonging to H such that f of x is equal to x of y for all y, for all x belonging to H, which implies that limit n approaches infinity. I've got x, जो ना इसको हमने define किया था x, x and n is equal to xy, right? What does that mean? That means that x comma x and n converges to xy. Should I write it like this? X and x converges to for all y belonging to n. Should I say for all x belonging to H? Sorry. for all x, this is unique, this is for all x belonging to H, fine. So which implies that, of course, by the definition of the weak convergence, right, इसको जरा flip करना पड़ेगा थोड़ा सा, अगर तुम्हें अजीब लगे, लेकिन you could flip it, क्योंकि वहां पे हमने ये void ले रहे हैं ना हम सेकंड पे, इसलिए हमें थोड़ा इसको flip करना पड़ा, but that's understood. So it would converge weakly to this y belonging to H. तो जो कि हम प्रूव करना चाहते थे, this is a subsequence of original sequence that converges weakly inside H. मैं चाहूंगा तुम इसको थोड़ा रफ पे करो, क्योंकि इसमें थोड़ा कैलकुलेशन है, कहीं पे अगर दिक्कत हो तो फिर मुझसे वो पूछ लो. Now we would like to come to what we call adjoint of a linear operator. So you know that for a bounded, so t belonging to pxy, जैसे हम कहते हैं, then इसका मतलब t is linear, ये तो हमें पता ही है, and of course norm of tx जो है वो less than equal to k times for all x belonging to x होता है, तो then we call this bounded linear operator from x to y. So of course inner product के लिए भी ये सब मतलब allowed है. So मेरे कहने का मतलब है every inner product space is a normal linear space, so ये definition valid है. Or then we can define t star, the conjugate of t जो है is defined as a bounded linear functional from y star to x star, जो कि हमने किया. ये जो t star है ये belong करेगा, it's a bounded linear operator from y star to x star defined by t star at y star is equal to y star composition t. और वहां पे हम लिखते थे usually t star, of course this is true for all, और या शायद मैंने ऐसे लिखा होगा t star at f is equal to f composition of t for all f belonging to y star. So this defines a map, इसको हमने define किया था conjugate. Now there is one thing, if I take Hilbert spaces, now suppose t belongs to a bounded linear operator from h1 to h2, right? Now what I do, so I can think of t star again. So t star should be a map from p h2 star by the same जो हमने अभी किया. लेकिन अब यहाँ पे एक ही चीज है, वो क्या, जब मैं लिख रहा हूँ t star या t star applies to some या ऐसे भी लिखता हूँ जैसे सिमंस ने लिखा है, let me copy it, right? So there is a correspondence between h2 and h2 star via Rees representation, one-to-one correspondence that preserves the norm. इसी तरह से there is a correspondence between h1 and h1 star. So what I'm trying to say, I start from h1, I start from h2, so let y belong to h2, right? So there is a corresponding thing inside, let me call that f sub y, right? So this belongs to h2, so this belongs to h2 star. अगर ये h2 star है, so t star जो है, that's a mapping from h2 star to h1 star. So I apply t star on it, so I get t star of fy. अब t star of fy कहाँ belong करेगा? So it belongs to h1 star, so this belongs to h1 star. But there is a mapping from h1 star to, so there would be some z belonging to h1, मतलब such that this is true. तो मैं कोशिश कर रहा हूँ इसको, मतलब ये तो खैर this was true for, this is true for any normal linear space. You define the conjugate. Now what I'm trying to say, let me make it again very clear. So t is a map from x to y. It's given. It's a bounded linear operator. So in our case now, let's call them h1 and h2, where they are Hilbert spaces. या इनर प्रोडक्ट स्पेस, ठीक है ना। So D star is a map from H2 star to H1 star. Now what I'm trying to say, I start with H, I start with Y belonging to H2, right? Then I जो हमारा रीज रिप्रेजेंटेशन थ्योरम है उसके हिसाब से there exists a functional in the door and there exists some Fy belonging to H2 star such that Fy at Z is equal to Zy for all Z belonging to H2. Of course, this Z is unique. This Y is unique. There exists this unique Y belonging to H2. So मेरे कहने का मतलब है, so there is a one-to-one correspondence between H2 and H2 star. I start with a Y, associate with its F sub Y. So I was inside H2, now I'm inside H2 star. Now T star acts on H2 star too. So I apply on Fy T star, so I end up with, where am I now? I'm in H1 star, but there is a correspondence to, let's call the Z, which belongs to, of course, H1. So via this map, because this at each of the terms there exists this unique vectors for every Y there is a unique Fy, and for every T Fy inside H1 star there exists a unique Z in H1. So I define Z to be T star of Y, which has this association. लेकिन अब चूंकि मैंने अब तुम मतलब now then T star is a map from H2 to H1, है ना, क्योंकि ये H2 में था और ये हम पहुंच गए H1. तो अब ये कॉन्जुगेट तो है, लेकिन कॉन्जुगेट इज डिफरेंट. दैट वुड कॉन्जुगेट कहां से एक्ट करता है? H2 star to H1. लेकिन Hilbert space में in particular I can do this thing, यानी I can make it into a map on vectors rather than functionals. तो जब मैं इसको ऐसे डिफाइन करता हूँ, इसको मैं मतलब नाम भी दूसरा देता हूँ, हम इसका नाम रख देते हैं adjoint of T. ठीक है? So that's our adjoint of T. So thus I can think like this. Should I write it like this? Now I can think like this. T star, should I write it as a theorem? चलो ऐसे ही करते हैं. T star f sub y, अगर मैं इसको act करूं on functionals applied to x होगा, of course by our जो definition है conjugate की, it would be fy of t of x. लेकिन fy of tx चूंकि fy corresponds to some y, है ना, मतलब like this. So this should be just inner product of tx comma y. मतलब यही है ना property of the inner product. I can change the functional by vectors via the these representations here. But I can also think of this t star at fy, right, as belonging to h2 star. So then it acts, I can think of this t star fy applied to x. I can think of this belonging to H2, yeah, H2 star. So there is a corresponding vector Fz of x. This belongs to H1 star. H1 star में है, तो there would be a corresponding F. इसको मैं सोच सकता हूँ as Fz. मतलब it has a corresponding vector in H1. This lies inside H1 star. So it would have a corresponding vector in H1, and x also belongs to H1, so it would be of the type x z, और इस z को मैंने नाम दिया है t star of y via this association. So अगर मैं ये दोनों को इक्वेट करूं, मतलब पहले मैंने इसको यूज किया डेफिनेशन ऑफ द कॉन्जुगेट एंड देन अप्लाइड द रीज रिप्रेजेंटेशन थ्योरम, और यहाँ पे मैंने पहले ही रीज रिप्रेजेंटेशन थ्योरम अप्लाई किया और फिर उसको एज एन इनर प्रोडक्ट रियलाइज किया, एंड and this association I denoted by adjoint. So इसका मतलब चूंकि ये दोनों चीजें लेफ्ट हैंड साइड बराबर है, I should have जो txy should be equal to xt star y. ये बहुत ही important मतलब एक रिलेशन है, बहुत ही important रिलेशन फिजिक्स में बहुत जगहों पे. So adjoint is characterized by this property. This is true for all xy belong to xy belonging, x belonging to h1 and y belonging to h2. Of course हम इसको h में भी reduce कर सकते हैं. वो कैसे? हम अपनी डोमेन और कोडोमेन को सेम करें. अगर हम t ले map from h to h, then t star would also be a map from h to h. Of course, then x and y would both belong to h1 and h2. तो यहाँ पे ध्यान हमें रखना है, t is a map from h1 to h2. So t star is a map from h2 to h1. तो चूंकि ये functionals पे जब act करता था, इसका नाम conjugate था. लेकिन अब चूंकि we can realize the functional as a vector itself, so this would act upon vectors inside h2, and we call it adjoint of t. लेकिन मैं इसको थोड़ा formally लिखना चाहूंगा. मतलब ये तो खैर एक तरह की डेफिनेशन है. फॉर्मली लिखने का मतलब, अगर कोई कहे एडजॉइंट क्या है, हम कहेंगे भाई ये जो भी इसको सेटिस्फाई करेगी कोई फंक्शन t star from h2 to h1, so that is the adjoint. Well, this is the defining property. So let me write it as a small theorem. The adjoint t star of t belonging to bh1 h2, where h1 h2 are inner product spaces, is characterized by tx inner product with y is equal to xt star of y. हम कभी कभी अब इसको लिखते भी नहीं ना, t के यहाँ राउंडेड ब्रैकेट on the argument of the function. We omit it most of the time. जो books होती हैं वो omit करती हैं. For all x belonging to h1 and y belonging to h2. And of course t star is a map from h2 to h1, which has this relation. Proof but a simple one. Now let y belong to h2 and define f from h1 to k by f of x is equal to tx comma y for all x belonging to h1. Then f is linear. That's obvious because t is linear, f is linear, t is a bounded linear map. Then f is linear, and of course on h1, and modulus of fx is equal to modulus of inner product of tx, and using the Cauchy-Schwarz inequality, using the property that this is a bounded linear map, this is less than or equal to norm of t into norm of x into norm of y. So अगर हम y को फिक्स करें और t तो खैर फिक्स्ड है ही, तो it's a bounded linear map because this को हम as k treat कर सकते हैं. This is true for चलो लिख देते हैं. That is mod of f of x is less than or equal to norm of t. They are just numbers, we can commute them. For all x belonging to h1, it implies that f belongs to h1 star. So therefore, by Reed's representation theorem, there exists a unique z belonging to h1 such that f of x is equal to xz. We define z equal to t star of y, so that t star is a map from h2 to h1. तो हमने शुरू किया था h2 में, and we found a unique thing in h1. So this defines a mapping, and we are getting an association uniquely for each y. There exists a unique set, so it defines a mapping. और इस mapping को जो इस process के जरिए मुझे मिला, उसका नाम मैंने रखा t star. Right? So तो अगर मैं इसका नाम रखूं t star y, अब f of x से बराबर इसके और f of x से बराबर इसके, so that तो we get, so that जो हमें चाहिए कि tx inner product with y is x inner product with t star of y for all x belonging to h1, y belonging to h2. So these are properties of this. This is the adjoint of t. अब इसकी कुछ properties है which I should आज करें. चलो आज रुकते हैं, next time करेंगे. So let's leave it here. तो attendance 14. एहतिशाम, तुम्हारा CIA कब है सेकंड? कुछ उसका फिक्स हुआ कि सब सो रहे हैं? हेलो, कैन यू हियर मी? कैमरा ऑन करो सभी. सो रहे थे? हाँ, तुम्हारा CR कहाँ गया? वो तो चला गया, उसने फोन ऐसे ही रखा और चला गया. हाँ, मुझे पूछना था तुम्हारा सेकंड CIA के बारे में. चलो अब कल बात करेंगे. So let's end it here. कितने आए? 13. आज कम ही है.